The Hubble Space Telescope has been in space for a long time. Launched in April 24th, 1990. That's a long time being up in space and being a stalker, and before our time as well. But the thing is, the Hubble has made several discoveries that we would come to admire in the times ahead and later question. However, the Hubble telescope is slightly outdated, so we will talk about another telescope that will honestly be one of the greatest feats done by man, besides putting one on the moon. Crazy how that works. The James Webb Space Telescope, JWST, or JOUST, or Webb, for simpler reasons. Today we will be gazing into the starry sky and looking at the telescope and its functions. Then we'll look at a few discoveries and how they will affect us going forward, and then perhaps an understanding to why we will use this. Interesting enough, space is interesting, and so are we. So let's go to a not so distant planet, like literally DC, our capital, because as the Mando from The Mandalorian once said, this is the way. Hubble's first images were astonishing and mind-boggling. However, they were produced by a telescope built in the 80s and literally took 20 years to build and put all the sciencey stuff in. But we are now in a golden age of technology where scientific instruments that can help us identify cancer cells and see sunspots on the sun. What if we took all of that information and stuffed it back into another telescope, only better? The James Webb Space Telescope. Now, the research that went into building this telescope took a whopping 30 years, and the launch was literally last year in a couple months, or literally next month. Now, there are 4 cameras on board this telescope, and naming them would be a bit much, but frankly, they can be a topic of their own. But simply said, 3 infrared cameras, 1 imager, 1 spectrograph, and 1 sightless spectrograph. This telescope has shown us its power and its true potential. Now you may be wondering, why the infrared? Well, to my knowledge, I have no clue. But according to the James Webb Space Telescope website, otherwise known as NASA, claims that by viewing the universe at infrared wavelengths, Webb will show us things that we have never seen before in any other galaxy and by any other telescope. It is only at infrared wavelengths that we can see the first stars and galaxies forming after the Big Bang. And with infrared light, we can see stars and planetary systems forming inside clouds of dust that are opaque to visible light, essentially saying that we will now be able to see past gas clouds out there in space, seeing right through the pillars of creation, as they are simply just clouds. Now Webb, according to NASA, can see around 250 million light years to possibly 100 million light years after the Big Bang, when the first stars and galaxies started to form. Now that is something Hubble cannot do. When the first images of Webb came back, now keep in mind these were just the first images, and they were just for calibration for each camera. And with that, each camera shot into the abyss, essentially. And the images that were created were so clear that they could show every galaxy from the furthest away to the closest. Space.com, September 7th, 2022. Webb is designed to find the earliest galaxies in the universe. One of the things it's found in those galaxies are possibly more massive than we thought. At the same time, another surprising thing is, galaxies have a lot of structure and are well organized in the early stages of its life. We, as a species, should applaud and cheer for the accomplishments in our own advancements in our technology. Now, it's no Star Wars, but that shouldn't bring us down. As Yoda once said, do or do not, there is no try. So let's take a detour to our favorite Jovian planet. Jovian, meaning gas, and no, not Saturn, although it balanced out our system along with Jupiter, and that guy helped us protect our small little blue planet from asteroids. I'm talking about Neptune, the last planet in our system. And if you still believe Pluto is a planet as well then by means, talk to NASA. According to the Voyager 2 by NASA, it is the first spacecraft to ever do a flyby of the gas giant, characterized Neptune as an ice giant comprised of mostly hydrogen, helium, and methane. So the images it captured of Neptune are just a big blue ball floating in space, with planetary movement and the cloud formations and the life cycle of the great storm occurring on the planet, along with the images of its brightest and most oddest moon, Triton. But the limelight really goes to Neptune, but not from the Voyager, but to Webb. Do you remember the 21st night of September? Because I do. That was a Wednesday. The images of Neptune done by Webb were enough to get you saying, damn, that's amazing, or whoa. That's how you should react. Webb showed off its capabilities with its infrared cameras capturing the planet's rings since 1989, and it reveals the blue ball in a stunning new way. Webb shows off Neptune's fainter dust bands, and the rings are a sight to behold. We can see the moons that follow the blue planet. To see the planet this far away and that amount of resolution is absolutely phenomenal. Now, the sight of Neptune is wonderful, but this also brings the question: if the images of Webb are so clear, why isn't that the CCTV camera at my local 7-Eleven doesn't have that? In short, the cameras were switched to infrared, and because of that, it was able to capture the planet's methane clouds and its rings earlier this year in August 22nd, 2022. Webb managed to capture the images of Jupiter with some light similar to Earth. The sibling images were both captured in near-infrared cameras, according to astronomer Elise Fisher. States that the images produced by Webb showcases Jupiter with giant storms, powerful winds, auroras, and extreme temperatures and pressure conditions. Jupiter has a lot of issues. Webb compiled the photos of Jupiter from the same article of Webb's Jupiter's images showcase, auroras and hazes, where it shows us the auroras extend into high altitudes above both the northern and southern poles of Jupiter. The auroras shine in a filter that is mapped to redder colors, which also highlight light reflected from the lower and upper clouds. A different filter is mapped to yellow and green hazes, showing the hazes around the northern and southern poles. A third filter mapped to blues showcases the light that is reflected in a deeper main cloud, like the red cloud. Amazing. This technology, that pushes up us so far in our astronomy. Now let's take some time to make some understanding of this telescope and why it's so different. Webb is different from Hubble in every single aspect. The way it creates images, the technology that prevents it from heating up when it gets too close to the sun and its sun rays. The telescope has heat shields, 4 different cameras, 4 different uses, 18 special lightweight mirrors, and it took 14 stops in 11 different places around the US to complete the manufacturing, according to NASA James Webb Space Telescope website. The reason this is so different is because not only can it take amazing photos and show us different settings due to its mirrors, but rather that it can also measure the use of cameras. So let's start off with something that would blow our minds. The carbon-based recipe for life on Earth is way more common than you think. Imagine the same ingredients for Earth, like planet. In a galaxy far, far away, a planet that exists just like Earth has a wonderful name of WASP 39b. Same as Saturn with a diameter of 1.3 times of Jupiter, the planet is cooler and more compact to our gas giants in our system. Now that alone is enough to get you thinking that we are not alone in the universe, as our ingredients for life are so common. Now turning away from that, we will explore one more thing: this telescope and its cameras. And the thing is, it's absolutely amazing. According to the frequently asked questions on NASA's website, star and planet formations in the local universes take place in center dusty clouds obscured from our eyes at normal visible wavelengths. Near-infrared light, with its longer wavelengths, is less hindered by the small dust particles, allowing near-infrared light to escape dust clouds. By observing the emitted infrared light, we can now penetrate the dust, and we can see in processes leading to stars formation and planets formation. So today, we learned about the telescope and its functions of its cameras. Then we talked about the photos of Neptune and its wonderful clouds. Then we discovered that our ingredients for life are not so rare. So while we are pondering the situation of the cosmos, we should be happy of the overall advancements in our technology and should celebrate these upcoming discoveries with open arms. Space is a wonderful topic and something that we should create more mechanisms that would help us as a species advance forward. This is our destiny, and with that, we will continue to aim for the stars, no matter how far they may be.